So thanks for joining. My name is Moshe Milman. I'm one of the co-founders of Applitools. I'll be presenting today how to level up your Selenium test with visual testing. And my main goal of this presentation, the main takeaways that I would like you to take out of this presentation is that you can and should automate your visual tests. I got a chance to speak with many companies in the past 2 years about test automation in general. And when I ask people if they're doing visual testing, the common answer that I'm getting is either, yeah, we're using Selenium to test the UI, or just saying, yeah, we tried Securely in the past, didn't really work for us, the maintenance was too much of a pain, or yeah, it's visual testing is just too much effort and too much maintenance. So I would like, and I'm going to show you some examples during the session today, but I would like you to take as a takeaway that it's possible to do visual testing. You should do visual testing. It will be very cost effective if you start doing visual testing. And I don't want anyone to tell me that Securely is visual testing. I mean, Securely is a great tool, but it was built initially not for visual testing. It was built for functional testing, and the main purpose of Securely initially was if you had problems detecting elements in order to click on the elements by the properties, then you would just detect the element by the image. So if you would like to find the submit button and click on it, it's okay to find something that will look not exactly like submit button, but if you want to do full page validation and full UI validation, Securely is not the right solution. So what we're going to talk about today, we're going to start by explaining what is visual testing, or agreeing at least on what is visual testing. We'll understand why it's important to do visual testing and what are the benefits of visual testing. We look at some tools and technology. I'm going to share an overview of some of the leading tools that are available today. We're going to see some examples of how to build an end-to-end visual test on top of Selenium with some open source tools. You're going to see it step by step. You can see how easy it is to build such tests. And then we'll see where does it fit in the life cycle of software development. So let's start by defining what is visual testing. So basically what visual testing actually means is validating all the UI aspects of your application on all the different platforms, making sure that your end users will actually see your application the way they're supposed to see it, no matter what platforms they're using to view your application, and making sure that all the UI elements will appear correctly on like the appearance, the fonts, the layout, the content, will be correct, that elements are not overlapping one another, not covering one another, not hidden on specific devices. All these things should be validated. This is one example of a visual bug. This is actually from our Microsoft Azure portal. So when you resize the screen, you can see that the graph goes beyond the boundaries. This is another example from Financial Times for the iPad application. You can see here that the title overrides the text. You can probably see it at the bottom here. And I have a bunch of other examples, but just to show what I mean by when I say visual regressions or visual defects, so these are some of the examples. Okay, so why should you actually care about visual testing, and why should you spend efforts automating your visual tests? So the first reason is that the test matrix is just too large to approximate it manually. I mean, you have today a huge amount of web browsers, mobile devices, localizations, operating systems, screen resolutions, responsive design. It's just impossible to test it manually, especially if you're looking at continuous delivery and continuous deployment, and I'm sure that many of you are already starting to do continuous delivery, or at least in the process of moving in that direction. And even if you're doing some level of agile release with weekly or bi-weekly releases, it's almost impossible to validate the UI manually when you release so frequently. A few years ago, when you used to have like an annual release, that's fine. I mean, you spend 1 month at the end of the cycle and you validate the UI. Not such a big deal. You do it just once a year. But nowadays, when you do it once a week or once a day or several times a day, you can test it manually. Another reason is visual testing is error prone. I mean, if you have to test the UI manually and if you have to do it over and over again, even the best QA engineer will still miss some issues. Okay, so we're just told that we have 1 hour, so I'll try to think about what we're going to do in the extra 15 minutes. I'll try to do like a dance show, but we'll see if we have time for that. So another reason why it should be automated, when you look at the mobile applications, the situation is even more severe, because if you have like a web application, a cloud-based web application, you release the product, you have a visual bug. If you find it quick enough and you fix it, maybe no one will even notice it, or just a fraction of your users will notice it. Maybe it's not such a big deal. But if you have a mobile application and you release it and people actually install the application, until you get a chance to fix it and deliver the fix to them, and until they upgrade the application and get the fix, this can take longer, and people don't like to update their apps frequently, so you're going to pay for that. And the last reason, which is very, very important, is that people are already doing it. Many companies are already doing visual testing and doing it successfully. So if you look at Facebook and Google and BBC, and many of these companies, when they saw the need for visual testing, they actually developed their own tool, because a few years ago there weren't any good solutions for visual testing, so people started developing it on their own. And I'm including here a few examples of some of the leading tools which are available today for visual testing. We're going to dive deeper into some of these tools during the session. But you can see Google developed this DPDXT tool, Facebook developed one of their own solutions, Huxley also came up with a great tool. We're going to drill down to the details very soon. But another thing that is worth mentioning, I think that in the past year, I've seen probably at least 10 new visual testing, open source visual testing solutions, just emphasize the need. So many people encounter this need, and because back like a year ago, there weren't so many good solutions, so people started developing it, and it's a huge trend now. All the analysts are speaking about it. If you ask Gartner and Forrester and all the leading companies, everyone are saying that visual testing is now the new trend in test automation. So if you're not doing it yet, you should start looking at it. So what's the workflow to do visual testing? All the tools that I showed in the previous slide are based on the same flow, the same structure of action that you do to build a visual test. The first one is to drive the application under test and take screenshots. Just move from one page to another, take screenshots of all the pages of your application, so you get sort of a coverage of your entire application. The second step is to compare the screenshots, compare it with a baseline image. The baseline image can come from a previous version of the application or from another environment. The next step is to report the differences. If there are differences, you need to report and show it in some way that is clear to the user. And then at the end of the process, you have to update the baseline. Basically, you detected some issues. You need to decide if these issues are legitimate evolution of the application or desired changes, and then you accept the changes and update the baseline. Or if it's a defect, you report a defect, you keep the old baseline. So these are the steps. And the main challenges are in the second step and in the last step, because driving the application under test, you're all using Selenium, so you know it's not easy, but it's doable, and I guess most of you are already doing it. So taking your application, moving from one page to another, that's not difficult, it's easy to do. Comparing the screenshots is difficult, and we're going to see some examples why it's difficult and how it can be addressed, but you have some pixel shifts, rendering differences between graphic cards, different environments, lots of examples that we're going to drill down later. That's one challenge. And updating the baseline can also be a challenge, because if you have, let's look at it here. So when looking at the scalability challenges, when you have a large-scale web application, for example, with 100 pages, and then you make a change to the header of the website or to the logo of your website, this change can potentially affect all the 100 pages. And then you run the test again, it will detect 100 differences, and you will need to look at the differences one by one and accept them, which can be painful. So some of the tools are providing help here with some level of automated or automatic maintenance. Dealing with multiple baselines can also be a challenge. I mean, if you run your test, because it's visual test, so you'll have to have separate baseline for each environment, or at least separate baseline for each responsive layout. So again, maintaining the baselines can be challenging, but again, some of the tools are providing solutions. We're going to look at that. And in the image comparison, we're going to drill down to that, but false positives is a big pain, and dynamic data is also a challenge. If you're dealing with an application which you don't have a way to control the data that you're getting in the results, like news web pages, e-commerce sites, getting like a fixed data can be a challenge, but you still would like to be able to validate the layout of your website. You want to be sure that the layout looks right even when the data changes. Sorry. So let's start with a quick demo. The demo that I'm going to show you right now is of a tool that is called WebDriver CSS. That's an open source tool that is built on top of WebDriver IO. WebDriver IO is one of the more common implementations of Selenium in JavaScript. You have WebDriver JS and WebDriver IO. These are the two most common JavaScript frameworks. And let's go. Let's see. Is it large enough? Can you see the code even in the back? Perfect. Okay, so let's start. Okay, so this is how a WebDriver IO test looks like. It's the idea is what we're going to do. We're going to look at a test like step by step, how to take a WebDriver IO test built on top of Selenium and then scale it to be a visual test. So what we have here is a very basic test. We just opens Chrome, goes to a specific URL, that just opens a GitHub page and then waits for 10 seconds. So let's just go ahead and run this test. So what will happen now, it will just open the browser. We'll open the GitHub page, but it doesn't do anything. It's like just open the page, didn't do any validation. Now after a few seconds, it will close the browser. So that's the basic test that I created, and on top of this, we're going to add some visual validations. Okay, so we have this test, it's finished now, and now let's go to the next step. So now what we would like to do is use WebDriver CSS. As I mentioned, it's an open source tool. I highly encourage you to go online and search for this tool and install it. It's a few simple steps to get it installed. And basically what I added here, so I have the WebDriver IO code. I'm just creating this WebDriver CSS. Basically, when you initialize WebDriver CSS, you have to define what screen sizes you would like to validate, what screen widths you would like to validate, just because the application might look different, different sizes, on mobile size or tablet size or laptop size. So in this case, just for the example, I selected 1200 and 1100. And then what I'm actually doing, I'm opening the URL again with WebDriver IO, and then I'm defining a new test in WebDriver CSS. In this case, the name of the test is GitHub, that's just a name. And then I'm defining the page that I would like to validate, or the elements that I would like to validate. In this case, if you can provide here any web element, you can just test the header or the footer or just a specific element. But if you choose body, it will just validate the entire page. So in this case, we choose to validate the entire page. We just give a name for the element. I called it body as well, but you can choose any name here. And if we're going to run the test now, so now it will open the browser again, but now it will also take a screenshot of basically it does automatic scrolling and stitching of the image, so you get a full page screenshot. Even on Chrome, you probably know that with WebDriver, if you capture a screenshot on Chrome, you just get the viewport. So this tool is helping you, it does automated scrolling. And it did it, if you notice, it resets the size of the browser window to the size that I selected, initially 1200, then it did it again for 1100, and now if I'm going to go to the folder with the test results, not this one, yeah, this one. So now you can see that it created two images here. One is, the image is called baseline because I did it now for the first time. I didn't have any existing baseline. So it's the first time that I'm testing this application, it created a baseline. One for 1100 and one for 1200. If I'm going to open the image, you can see this is now the baseline. And now just to make it interesting, let's go ahead and inject some JavaScript code that will move one of the elements on the page 15 pixels to the right, and then we'll see what happens. So let's run it again now, and what will happen now? Now it will compare it against the baseline that we created earlier. So let's run this one. And now you'll be able to see, okay, it will open the page again, it will move, you see that the text on the top moves a few pixels to the right. Now it will capture a screenshot, it compares it against the baseline, we already have an existing baseline. And now when it's done, what you can see, I don't want to update my Java now, sorry. So you can see that it created two regression images because it detected a change. If I'm going to look at the regression image, you can see that in the regression image, I have this visual bug here. And it also creates a folder called diff. And in the diff folder, I can see the diff images with the actual, okay, in this case, I highlighted the screen. So this is one of the challenges of false positives that we're going to look at how to solve very soon. But it highlights the differences. And if I would like to accept the new image, I can basically run it again with a flag that says update baseline, and this will update the baseline, and from now on it will become the new baseline. But that's the basic idea. We'll look at updating the baseline in the next demo. So let's go back. Okay, so let's drill down into all the steps in the workflow and see what's important in each of the steps. So the first step is to drive the application under test and capture screenshots. So it's not a big challenge, but there are a few important things that you need to take under consideration. Now, when looking at driving and capturing, there are different sets of tools that approach it in a different way. The first column here is tools that are based on a headless browser. Do you all know what headless browsers means? Okay, excellent. So we have Phantom.js and we have Slimer.js. These are the leading tools. Phantom.js is built on top of the Safari engine, and Slimer.js on top of Firefox. And basically what this tool does, it just open a headless browser, capture a screenshot from the headless browser. So it's not a screenshot from a real browser, but in most cases it's close enough. The second column is tools built on top of Selenium or on top of some sort of implementation of WebDriver. So you can see some good examples here. WebDriver CSS, the one I just showed you, is built on top of Selenium. There are a bunch of other tools that are available here. And these tools are opening real browsers. So they're built to test web applications using Selenium. And the last column is like relatively newer tools that are built to test mobile devices. So the one from Facebook is currently supporting only iOS. WebDriver CSS will also have soon support for mobile as well. And there are some frameworks that support all the different environments. So when looking at screenshot, what's important to take under consideration? First of all, real browsers versus headless browsers, that's a question you need to decide. It's a long debate, so we're not going to get into the details now. Full page screenshots, again, that's a challenge with some of the tools. Some of the tools like WebDriver CSS give quite a good solution by scrolling the page automatically and stitching the images, so you can do full page screenshots also on Chrome and Safari and get consistent results with Firefox and IE. Frames, that's another challenge. If you have iframes on your page and the frame might have a scroll bar and part of the frame might not be visible when you open the page, so some of the tools also allow you to capture screenshots of frames, just scroll the frame and again stitch the content so you get a full page screenshot for the frames as well. Regions, if you don't want to test the full page, you can just provide CSS selectors or XPath and only test specific elements of the page. Viewport size, different sizes, that's also something to take into consideration. And page stabilization is probably one of the biggest challenges when looking at visual testing. You basically need to understand when the page finished loading before you take a screenshot. Otherwise, you're going to get a lot of stability issues. And that's a challenge, but some of the tools are also helping in a way that they retry to capture the screenshot until it reaches to a state where it equals the baseline image or until a timeout is exceeded. So if you expect your page to load within 2 seconds, if it doesn't load after 2 seconds, that's an issue. So this can also help you guarantee that the page finished loading. And instead of waiting for elements to finish loading, Oren mentioned a few examples in the previous talk. So this can also save you some of this work. Sorry. So the second part of the workflow, which is probably the most challenging one, is the actual process of comparing the screenshots. So Oren already showed these slides, but you don't just compare pixel to pixel and expect to have a match, because you're going to get a lot of false positives. So we'll see how some of the tools address this. So some examples why it's not recommended to compare pixels. So actually it's tough to see it, but this is just an image. And here we just took this small area from the image and zoomed in on this area. And if I'm going to toggle between 2 different images from 2 different machines with different graphic cards, it's difficult to see it, but you can see that many of the pixels are changing. And when you look at the actual image in a normal size, you won't see any difference. I don't think anyone would want to report a defect about it, but that's the kind of issue that you get when comparing screenshots. Another thing is anti-aliasing. For those of you who don't know anti-aliasing, what it means helping the graphic adapter to paint like a circle line or a curved line. Basically, because the pixels are squares, if you try to paint a curved line, you get sort of like stirs, just because, and in order to make it look like a circle to the human eye, the graphic adapters are doing what's called anti-aliasing. So just adding some visual effects on the edges of the lines to make it look like a curved line. So different graphic adapters render anti-aliasing differently. That's another example. You can see the changes in the pixels. Again, if you try to compare it on the pixel level, you're going to get huge differences. Movements of pixels. I mean, in this case, what you're seeing is basically an example. This is actually an example from the Dropbox website. Here you have like the username on the right side of the upgrade account, and because the username might have a different length every time, the position of the element might be different. So another challenge is to be able to deal with elements which might appear on a different position. And also in this case, when the element is rendered on a different position, you can see that the letters are changing. Can you see this movement of the letters? So that's also quite a significant pixel changes, but you need to be able to ignore these changes and not report a defect about it. And last but not least, brightness changes. Again, that's a similar issue. And more, of course, you have these single pixel movements, which can be the most annoying thing. If you have like Gmail examples that I'm going to show in a minute, sometimes one of the columns might render 1 pixel wider, and that's like can be 50% difference between the images. So you can't use thresholds. You can't say only if more than 5% are different, report an issue. Dynamic content we mentioned, like news website, that's also a challenge you need to deal with. Moving elements, images from different sizes, you don't always get the same size of the image. And that's always a funny image. You try to compare an image and get some mismatch. So, so let's look at the leading image comparison APIs that are out there and available. The first one is ImageMagick. ImageMagick has been around for quite a while. Anyone here using ImageMagick? Cool, a few people, great. So ImageMagick was initially built for different levels of image processing, but it also have the capabilities to compare images, and it has some fuzzing built into it to deal with some of the challenges that we shown earlier. And APIs for most programming languages, basically it's a command line tool, so we can just take two images, provide a link to the diff image, provide a threshold percentage, and just it will return you the number of pixels that are different, and also a diff image with the changes. And many of these tools are built on top of ImageMagick. We also have Resemble.js. That's a very cool. ImageMagick is free. Resemble.js is also open source. You can also use it. WebDriver CSS, the tool that I just showed you, is built on top of Resemble.js. They also have a very cool website where you just upload 2 images and it shows you the differences. It's quite nice. And they have some good support for anti-aliasing. They're doing some tricks to deal with anti-aliasing challenges. And we have the tool from ApplyTools. This is the commercial tool, but we're also going to open an open API just for the image comparison. So it will allow some of the open source tools are already using our engine, and they're just sending 2 images and get the results. So you don't get like the full capabilities of the tool, but at least the image comparison stuff is available, and it deals well with anti-aliasing, with image offsets, shifting. All the examples that we've seen earlier are dealt with by ApplyTools. The idea is that it means to be able to understand which changes are meaningful and which changes are not going to be noticeable by a human eye. Also dealing with dynamic content, you can just validate the layout of the page and ignore content changes, just make sure that the layout is consistent, and it's available as a cloud service. So let's see a quick demo of this image comparison. So, okay, so this is the way that this tool presents the differences. You basically see a baseline image on the left-hand side, an actual image on the right-hand side. You can see in this case, both images came from the same environment, from Windows 7, from Chrome, from 1024 and 768. And you can highlight the differences between the images. You can also drill down to specific issues just by zooming in and toggling, and then you can see here it captured a typo, and here it captured like a movement of the logo, and here it captured a color change of the button. So that's just an example, and you can decide if you want to test it in strict mode, which will detect any issue. You also have exact mode, which is like pixel to pixel, but it's not recommended. You have layout mode, which will just look for layout issues and will ignore content changes. And another thing that I didn't mention that many of the tools are providing a good solution for is that you can also ignore specific regions. I mean, one of the problems if you have advertisements on your page or different stuff that might be different every time and you don't really care to test it, you can also define mask elements or ignore regions. So most of the tools that I showed you provide some solutions for that, either by a selector that will ignore the region or just masking specific areas. Here you can also decide that you would like to, if I have like an advertisement here that is going to be different every time, I can just define it as an ignore region and just say that I don't want it to fail the test because of problems like this one. And if I have moving elements like the Google logo and I don't want to fail the test because of moving elements, I can also mark it as what we call a floating element, and it will automatically create a border around it. So as long as it moves within this area, that's fine. Okay, and by the way, you can also, if you want to look at dynamic pages, so you can also look at pages with dynamic content. So this is a page from Yahoo from 2 different days. You can see it's the same page, but just the content is different. So if you don't want to fail the test because of content changes, you just want to validate the layout, that's going to work okay. If I would use pixel to pixel or like a bitmap checkpoint to compare this page, you can see that it highlights everything. Even the side menu and the top menu, which didn't really change, are highlighted just because the pixels are rendered differently. This is part of the false positive stuff that we mentioned earlier. If I'm going to run it in a smarter way, it will only highlight the content changes, but it will understand that the side menu and the top menu are fine. And if I'm going to run it in a layout level, it will not highlight anything because the layout is perfectly fine here. And just last example to show you an example of how we can find a layout issue. So this is an example on a test on a mobile application. You compare between Samsung Galaxy S4 and Samsung Galaxy S5. Pages on Twitter, just different tweets, but you have 4 tweets in each of the examples. And in the baseline, all the tweets were aligned fine, everything is okay. In the actual result, I have some layout problem here. The text is overflowing to the left and a missing icon here. So if I'm going to run it in layout mode, it will only highlight these issues, even though like many other things change here as well, it just highlights the layout problem. So that's a dynamic data, and it can also be used to compare different browsers and different environments, but let's move on. So another important point is how to report the differences. Okay, so we compare the two images, we have some differences, now we need to compare between them. So here tools are providing different solutions. One solution is showing the diff images, like I showed you with WebDriver CSS, which just paints the areas in pink, the areas that are different. Another solution, and this one is taken from Selenium Visual Diff, that's also quite a cool tool, an open source tool, is that it shows you like a gallery. You see all the images, the expected images and the actual images, and you can drill down to each image and see the differences. And it also shows you a summary table with like how many images were tested, how many differences were found. And if we look at the last step, which is updating the baseline, this step, as we mentioned, can be quite challenging. So in some of the tools, what you need to do, you can either rename the files, like if you have the baseline file and the actual file, you can rename the files, and then by renaming the file, you make a decision that the new file becomes the new baseline, and you can just delete the old file. You can also run the test in override mode, just to show you. Let's go back to the WebDriver CSS example. So in WebDriver CSS, there is a mode that is called update baseline. And if I set update baseline as true, let's make sure to save it. Now the test will run again, and what it will do, it will override the baseline, and it will use the new image with the problem, with the offset as the baseline. So if I'm going to run it again now, just a second. It will now run again with the faulty image, and it will update the baseline. So the new problematic image will become the baseline. It will just delete the diff images. And that's one way to update the baseline. Usually in some tools, it also just allows you to see the differences and decide if you want to accept or reject the changes. And we can also see another example. In the example that we've seen earlier in the here, if we have the two images, and we can just decide if we accept an image or reject an image. In one of the open source tools with the gallery, it also have this option to accept or reject the baseline image or the actual image. And also part of the automated maintenance that I mentioned, which is important, and some of the tools are dealing with that in a way, is that if you have a change which affects multiple pages, in this case I have a test which covered 3 different pages, and in all the pages I have the same issue. I made some changes to the header in the top here, so it affected all the pages. So if I'm accepting the change in one step, I would like it to also scan all the other pages and look for similar changes. So in this case, if I'm going to now go ahead and accept the change, it automatically scans all the other changes in the test and accept any similar issues. And the same goes if I'm ignoring a region on a specific page. Let's say that I have a baseline for a mobile size and a baseline for tablet size and a baseline for a laptop size. Once I define an ignore region, I would like it to automatically create the same regions on all the other environments, so I will not need to manually do it. So some of the tools are also doing a good job helping you in this area. Okay, let's go back. By the way, any questions so far? Okay. So yeah, that's the GUI example of a tool called Gemini. Gemini is actually also a cool tool you recommend looking at. It's also an open source tool. So it shows you the differences. You just need to select if you want the baseline or the actual one. So let's see where does it fit. We understood now how to take a test with Selenium and make it a visual test or add visual validations to this test. Let's see where it can actually help us. So the first point I'm showing here, the pipeline, the continuous deployment pipeline. So the first point, when you look at the unit tests, and actually Oren did a whole talk about it, but you can actually do it on a component level. You can just take a specific window or a specific module and do visual testing on it as part of the unit tests. And it can also come very handy when you do code reviews. So when you look at the code changes, but you also see the UI changes, this can be very helpful in the code review process. And another level where it can be helpful is you can take some mockups from the graphic designer and compare it with the actual implementation, make sure that the UI implementation is consistent with the mockups. So this can also be used by the designers or the product managers to make sure that the implementation is consistent with the design. The next stage is the integration stage. So in the integration stage, you're actually looking at usually at full pages or like specific elements of the page, and you can run it as part of your Selenium test. So any Selenium test can include some, I mean, here are 2 most common approaches that I see. one approach, and I would say it's like 50-50 between these two approaches. One approach is some companies are actually taking their existing Selenium test, adding visual validations on top of it, and just making a sort of like integrated tests that are both visual and functional. Other companies, what they're doing, they say functional test is one thing, visual test is another thing. They just separate it to two different types of tests, and it's run separately, but it can basically, either of these options are good, and it can be used by developers, by QA, and by other people from the organization. Another important step is the acceptance test. So if you have the staging and production, and you would like before deployment to production, you want to compare staging and production, make sure that the UI is consistent between staging and production. That's a very common use case. Can be used by DevOps team or by automation teams just to last validation before you push to production. And the last point is, even after you push to production, if you didn't have the time to test everything before the deployment, after the deployment, you can also do some validation of the UI on the production, make sure that the deployment was successful, and also use it for monitoring. You can also monitor that the UI of the site is consistent after deployment. Now, where visual tests can actually run. So here you can either run it locally on your local browsers or local mobile devices. You can connect devices to your machine and run visual tests on your local devices. You can use headless browsers or simulators for mobile device, emulators, simulators, or real devices for mobile devices. You can run it on your local grid. You can run it on cloud browsers and devices. You have solutions like Sauce Labs and other, which allows you to run it on devices on the cloud. But basically, the answer here is anywhere. You can, if you have a way to use your Selenium or your test automation infrastructure to run tests and to drive the application and get screenshots, you should be able to do visual tests anywhere. And that's basically it. If you have any questions, I'll be more than happy to answer. No questions? Thank you. Thank you very much. Just want to take a picture.